Let's now discuss problem number 7. For the beam cross-sections shown, determine the flexural strength using NSCP 2015. The value of your F'C is 20 megapascal, Fy is 350 megapascal, and given yung beta natin which is equal to 0.85. So for this one, meron tayo dito na taas sa 200 mm. So thickness na 150 at each side. Tapos sa gitna, we have 200. And meron tayong effective depth from the center of your reinforcement to the outermost fiber of your beam in compression, which has a value of 725 mm. And meron tayo 5 peraso ng 32 mm diameter bars. So for this one, hanapin daw natin yung ultimate moment capacity or the flexural strength of your beam. So una-una sa lahat, since irregular yung section natin, tingnan natin kung hanggang saan yung value ng compressive force natin dito. So with that, so for your first step, so we will going to assume, so let's say, yung value ng compressive force natin is hanggang dito lang siya, hanggang sa thickness natin na 200 lang. So tatansyahin natin kung hanggang saan yung compressive force natin by means of etong mga tensile force natin. So with that, assume natin na A is equal to 200. Also, we will going to assume that tension still will yield. So if that still will yield, the value of your Fs is equal to the value of Fy. So unahin muna natin na kunin yung value ng T natin. So for this AS, Fy lang tayo. So meron tayong 5 peraso ng bakal na merong 32 yung diameter multiplied by Fy na 350. So yung value ng tensile force natin is 1,407.434 kilonewton. Then, ito yung ibabalance natin to the value of your compressive force. Kasi by analysis, your tension force must be equal to the compressive force. So ngayon, for that, para mabalance natin yung 1,400 na tensile force natin, so, assume A is equals to 200. Hanapin natin yung value kapag yung A is equals to 200. So, meron tayo dito na 0.85 F'C. So, yung F'C natin, that is 20 multiplied by A. So, the value of your A, that is 200 multiplied by. So, ina-assume natin na hanggang dito yung compressive force natin. So, meaning to say, etong dalawang area natin, so pwede natin silang pagsama. So pag-unite na lang natin yung dalawa, so meron tayong 150 plus 115, so yung value ng width natin, that will become equal to 300. So yung value ng CF natin is now equal to 1,020 kilonewton. So dito na nangyari is yung compressive force natin, nung kinonsider natin na A is equal to 200, since nag-less than yan sa T, so meaning to say, yung A natin is greater than siya dun sa given natin na thickness. Therefore, irregular yung section natin. Sir, paano po yung mangyayari ngayon? So, di ba kanina, kinonsider natin na tinansya natin kung hanggang dito, kung mag-e-equate ba siya dun sa tensile force natin. Kaso nga lang nagkulang siya ng 300 plus na kilonewton. So, kailangan natin i-increase yung value ng CF natin. So, paano natin i-increase yan? So, increase natin yan by means na dadagdagan natin yung area ng compressive force natin. So, instead na eto lang, yung area ng compressive force natin, dagdagan natin siya para mag-equate siya to the value na 1,400 kilonewton sa tension. So, let's say na eto na ngayon, yung magiging location ng A natin. So, since nalaman na natin na magiging irregular yung section natin, so, alam na natin na hanggang dito lang, hanggang dito yung value ng A natin. So, with that, kung hanggang doon yung value ng A natin, we can now set. So, pwede nating sabihin na, pwede nating So, pwede natin i-consider yung mga areas na to. So, meron tayo dito sa unang area. So, pagsama na lang natin yung dalawa. Okay, pag-combine natin, so that will become area 1. Tapos yung sa gitna, that will become yung area 2. Etong taas ng area 2 natin, that is A minus 200. So let us now calculate. So since irregular yung section natin, for the next step, C is equals to T tayo. For the next step, B, C is equals to T. So yung ano natin dito, assume tension still will yield the value of your Fs that is equal to Fy. So you have 0.85 F prime C. So since irregular yung section natin, gawin natin yung area compression is equals to AS Fy. So 0.85, the value of your F prime C is 20 multiplied by A sub C is equals to, meron tayong 5 piraso ng bakal na merong diameter na 32 mm squared multiplied by the value of your Fy, which is equal to 350 megapascal. So the value of your AC is now equal to 82,790.206 mm squared. So yung AC natin na to, that is AC is equals to yung area natin sa section 1 plus area dun sa section 2 natin. So ngayon, so what will be, so yung AC natin, that is 82,790.206. So yung A1 natin, eto yan. Okay? So meron tayong taas dyan na A. So meron tayo dito width muna. So 150 plus 150, so you will have a total width of 300 multiplied by A, o yung taas ng rectangle natin, plus yung area natin sa gitna. So we have a width of 200 multiplied by the height of A minus 200. So by shift solve, we can now calculate for the value of your A, which is equal to 245.580 mm. So which is greater than 200, so tama yung assumption natin. Therefore, we have a irregular section. So with that, hanapin natin yung value ng C natin. So yung A natin na 245.580, divide natin by the value of your beta. Since NSCP 2015, yung limiting value is 28 megapascal, yung actual natin is 20. 20 is less than the limiting value. So beta is now equal to 0.85, and you have a value of your C which is equal to 288.918 megapascal. After that, we will going to check if our assumption is correct since we have the value of your C. So since ano lang naman to, single reinforced beam, kunin natin yung value ng Fs natin, 600, yung effective depth natin na 725 minus yung C natin which is equal to 288.918 divided by 288.918. So the value of your Fs is now equal to 905.618 megapascal. So that is greater than to the value ng Fy natin. Therefore, assumption correct. Tension still yields talaga. So with that, kapag nakuha na natin na nag-yield ba yung bakal or hindi, let us now calculate for the value of your flexural strength, which is denoted by etong reduction factor multiplied by the nominal moment. So yung tanong ngayon is, what will be the value of your reduction factor? Okay. So mapapansin natin dito, yung reduction factor natin. So meron tayo ditong tension control, transition zone, at saka yung compression control natin. So what will be the value of your theta? So dito ngayon, sa pagkuha ng reduction factor natin, yung magiging basis natin is the value of your Fs na lang. So eto yung other ways natin sa pagkuha natin ng Fs. So from tension to transition zone, yung limiting value natin dyan is we have yung value ng Fs natin, yung actual, na 1,000 megapascal. And from transition zone to your compression zone, compression control, so yung ano natin, the limiting value is Fy. So in this case, yung Fy natin, that is 350 megapascal. So yung 1,000 constant to ha. And kapag naman nasa tension control ka, kapag nalagpasan mo yung 1,000 megapascal, the value of your reduction factor is 0.90. Kapag naman na-lessen ka dun sa given na Fy, so your reduction factor is 0.65. And kapag in between ka sa 350 at saka 1,000, so we're going to apply linear interpolation para makuha natin yung reduction factor. Or you can, pwede ninyong gamitin yung mga yung formula natin. Pero I advise na wag na natin gamitin yung mga formulas na yon kasi baka mahirapan tayo sa board exam at saka ma-occupy yung space natin. Ang dami kasing formula na i-memorize pa. So let's now calculate for your reduction factor using linear interpolation. So una, sa linear interpolation, lagi naman ang upper limit muna. So gawin nating upper limit, etong 0.90 natin. Minus yung lower limit. So yung lower limit natin is 0.65. Over, so yung upper limit na kinonsider natin na 0.90. Minus yung susunod niyan, which is dito sa transition natin, which is ito yung hinahanap natin na value, reduction factor, equals, so at 0.90, kung yung reduction factor, what will be your boundaries in that? So yung natin dito, yung stress natin, that is 1,000. Minus, kapag naman 0.65 yung reduction factor natin, what is your limiting value? Etong Fy natin na 350. Over, so yung upper limit natin na 0.90, yung stress na corresponding sa kanya is 1,000 megapascal minus yung reduction factor na hinahanap natin, which is at actual, so the value of your Fs is equal to 905.618 megapascal. So the value of your reduction factor is now equal to 0.864. So ngayon meron tayong reduction factor, we can now calculate for the value of your MU. Kaso nga lang may problema, what will be the value of your nominal moment? So that will become the compression force multiplied by D minus Y bar. So sir, paano po nangyari yun? So right now, yung gagawin na lang natin is we're going to consider na buo na lang yung natin dito. So eto na ngayon yung compressive force natin. So meron siyang intensity na 0.85 F'C. So yung 0.85 F'C na to, in a 3-dimensional manner, naka-apply siya sa buong area natin dyan. So with that in mind, so para mahanap natin yung value ng natin dito, yung value ng nominal natin dito. So if we were going to further elaborate the formula, so C is equal to 0.85 F'C. So ito yung other way natin, no? Sa mga previous examples natin, pinaghati-hati ko sila kapag irregular section. So dito naman, gagamit tayo ng Varignon's theorem. So AC multiplied by D minus Y bar. So bakit Y bar, sir? Kasi nga, hahanapin natin ngayon, diba, D minus Y bar, kasi irregular yung section natin. Magbabarignon theorem tayo para makuha natin yung distance. Okay? So let's say, ito yung natin, C natin. So di natin alam. So dito from this, di natin alam yung distance, kaya dinote natin na Y bar. So yung distance between the compression and the tension, isahanapin natin yan. Okay? So from here, hanggang dun sa dulo ng compression, that is D. This is D. Meaning to say, the distance between the tension and the compressive force is equals to D minus Y bar. Okay. So with that, hanapin muna natin yung centroid natin. So Y bar. How we will going to calculate for the value of your Y bar? So Varignon's theorem muna tayo. Hanapin muna natin yung mga area natin. Area 1. So we have a base of 150 plus 150. So you have 300. And we have a height of A, which is equal to 245.580. So we have a value of your area which is equal to 73,674. And for the value of your area 2, that is 200. So eto yan, base, multiplied by the height na A minus 200. So you will have 45, 45.580. So area 2 is now equal to 9,116. So after nating ma-compute yung A1 natin, yung mga areas natin, hanapin naman natin yung mga individual centroids natin with respect or with reference on the top part. So gawin nating reference yung nasa taas. Kasi yung reference ng y-bar natin is from the top part. So ito yung magsisilbing reference natin for our variance theorem. Yung taas yung magiging reference natin sa pagkuha ng mga y-bar natin. So, kunin natin yung mga individual centroid ng mga area natin. So, y1 natin. So, we will have, eto yan, kalahati ng A natin. So, A over 2, you will have 122.79. Yung y sub 2 naman natin, that will be, so 200 plus yung kalahati ng A minus 200. So, you have a value of 222.79. Okay? So, yung reference nila, ito yun yung y1 natin. So, ito. So, yung reference niya from this hanggang dun sa top part, that is y sub 1. So, from the center neto hanggang dun sa top part natin, that is y sub 2. So, hanapin na ngayon natin yung value ng y sub bar natin. So, una is yung total area ng compression natin. That is area 1 plus area 2, which is equal to 82,790 mm squared. So, hanapin natin yung value ng y bar natin. So, yung area natin, i-multiply natin to each individual centroid. So, meron tayong 73,674 multiplied by yung y1 natin na 122.79 plus 9116 multiplied by 222.79 over yung total area natin na 82,790. So the value of your y bar is now equal to 133.80 mm. And for that, hanapin naman natin yung value ng nominal moment natin. So for this one, nominal moment, so that is 0.85, yung F prime C natin, which is equal to 20. Yung A natin, yung area natin, so yung total area natin na 82,790 multiplied by the moment arm na D minus y bar. So yung D natin is 725 minus yung y bar natin 133.80. So you have a nominal moment which is equal to 832.073 kilonewton meter. Hanapin natin yung ultimate moment. So yung reduction factor natin na 0.864, multiply natin sa nominal moment natin. So you will have a value of your ultimate moment capacity na 718.911 kilonewton meter. So that will be the value ng M sub U natin.